Today's topic, ion drives and solar flares. How to answer the universe's biggest mystery. In today's video, we're going to discuss how ion drives work, how solar flares work. We're going to review the greatest cosmic mysteries in astrophysics, at least some of them, and then we will attempt to answer or better explain those mysteries. This is going to be a longer video than usual, so I will just go into brief descriptions of the mysteries when we get there. But first, let's talk about this beautiful thing. This is an engine, or more specifically an ion drive. It was developed by NASA and is considered one of the most efficient engines ever made. Now, I won't go into detail about how it's put together. There's some basic idea there. You can do more research on your own. I'll provide links in the description. But basically, they're going to be using it on all their satellites, and it can go in any direction they want it to. It's just an amazing thing. So, basics. Ion drive, it uses a magnetic field to propel ionized gas out the back. So it uses a magnetic field that we've discussed, positive, negative charge, and then ionized gas is either positively charged or negatively charged gas, and when this is expelled, it provides thrust. So this is what NASA's using to move their satellites all around the solar system ever since it was developed about, I think, 20 years ago. All right, let's discuss solar flares. Now here's a picture of a flare. It's a little bit bigger than Earth, as you can see, but it uses a magnetic field to propel ionized gas. And that's what we're seeing in this picture right here. Here's a diagram to explain a little bit more how it works. Again, more research or links in the description. But both ion drives and solar flares use the same mechanism for thrust, magnetic field, which propels ionized gas. Now, I don't know about you, but those seem awfully similar. And if we think about it a little bit, it kind of sounds like stars have a gigantic, omnidirectional, built-in ion drive and a gas tank with probably unimaginable range. That's kind of what it sounds like to me. I don't know about you. Anyways, let's discuss the greatest cosmic mysteries. Come back. I sent you way too soon. The greatest cosmic mysteries of all time. I'm just going to go over roughly what these are. I'm not going to go into too much detail, but I will put links in the description. If I went into full detail, this would be 3-hour videos. So just the general ideas. Let's just go over them real quick if you want to do some research before you continue. Galaxies rotate too fast. We don't know why. We don't know what the shape of the universe. Well, we know what it is, but we don't know why the shape of the universe is. We don't know why the structure of the universe is why it is. We don't know why everything is redshifting. We think we do, but we don't know why. We don't know why Mercury has an unusual orbit. We don't know why Venus has a greenhouse. We don't know why Earth experiences dramatic climate shifts. We don't know why pulsars exist. I'm going to offer hopefully a better explanation for black holes and quasars, a better explanation for time dilation, and a reason why dark energy and dark matter might not exist, and why fusion energy will probably never work. But before we answer the questions, we actually have to have a theory or a hypothesis that we can use to answer that. So, we have to have a thought experiment. Let's do a basic one. This is a stellar nursery, a gas cloud where stars form, usually located at the center of galaxies. There's another view. So, the thought experiment's a really simple one. We're going to use a stellar nursery. So let's bring up, there we go. And we have a sun. That's you. So the question is, you're a new sun, a stellar nursery. What do you do? What do you do when you're newly born like this? There's a big gravity well. What do you do? Now, before you answer, I do want to remind you that stars have a planet-sized, free-floating, factory-installed ion drive with enough fuel for quite a joyride. So again, we go back to the star at the stellar nursery, and we'll call this star Bob the star. Now, you know what? I think we can do better. Stella the star. Okay, so we have Stella the star. And what does Stella say? Oh dear, if I stay here, I might perish. Whatever should she do? She has an ion drive in regards to her solar flares, so she should activate her solar flares and move away from anything dangerous so that way she can stay safe. And so here she is, she's flying away. Stella the star is now closer to safety. So the hypothesis we can come up with is very simple. We'll just say when a star is formed, it moves away from all other stellar objects. So when a star is formed, like Stella the star, it moves away from everything else. So now we start plugging that into the theories and see what we get. Our first problem to try and solve is that galaxies spin too fast. In order to explain this, we have to look at how scientists say they think the galaxy moves, and for that, I have to go to the board to make it easier on myself. All right, so with the help of Bigfoot here, hello Bigfoot, let's take a look at a stellar nursery. That's where stars form, usually in the center of galaxies. So with the gas spinning for some reason, a star is formed, and by way of gravity drag, much like how you get pulled outwards, when you used to spin on one of those carousels as a kid, you know, the faster it went, the harder it was to hold onto the bars. So the star is flung out, and because of how gravity works, the star makes a curved trajectory. If we repeat this with many stars, we have a galaxy that should be spinning slowly. How slow? Well, that requires supermath, I'm guessing, to understand. So now let's take out our hypothesis. When a star is formed, it moves away from all other stellar objects, and apply it to galaxy spin. I have to go back to the board again. Oh, here's our buddy Bigfoot just hanging around. Hello again, Bigfoot. I'm going to call this pulsed ion, which is kind of what solar flares are, a pulse of ionized gas. All right, we have a stellar nursery. Gas is not spinning, just to make it easy. And here's a new star just formed. What does it do? Well, it moves away from the nursery as fast as possible, and as it moves, the gravity from the nursery will deflect it, just like it was doing in gravity drag, because that's how gravity works. If we repeat this with multiple stars, we get the same galaxy, but it is spinning faster than with gravity drag. So it's spinning the speed that we see. It's not spinning too fast. So let's give ourselves a little check mark here. I think this explains better the speed at which galaxies spin than assuming it's just gravity drag. Second mystery, shape of the universe. According to what we see in our telescopes, the cosmological principle is a theory that the spatial distribution of matter is homogeneous and isotropic when viewed on a large scale. This means that the universe is uniform in all directions. So if we apply our hypothesis, a star will move away from all other stellar objects. This would make the universe uniform on a large scale over time and over distance. So let's call that a check for better solving that mystery than, I don't know. Mystery 3 is related to the last mystery, but this has more to do with the internal structure of the universe as opposed to its overall size and shape. If we look at a picture of a portion of the sky, we see what looks like a web of stars, basically voids surrounded by shells of stars. I'll highlight to make it easier to see. So let's take our hypothesis. When a star is formed, it moves away from all other stellar objects, and apply it here with the stellar nursery in yellow. As a star is formed, it flies away from the center And eventually, when the last star is formed, it also moves away from the center, leaving a void surrounded by a shell of stars. And that is exactly what we see all over. This void surrounded by stars. So let's call that a check, or at least a better explanation than some sort of invisible dark matter. Let's head to mystery 4, redshift. What is redshift? Well, let's take a look at Hubble's law for an explanation. Hubble's law is the observation, again, just an observation, that galaxies are moving away from the Earth at speeds proportional to their distance. In other words, the farther they are, the faster they're moving away from the Earth. Now, if you expand on this logic like Hubble did, he concluded and convinced everyone else that the universe must be expanding. Let's take a look at why this conclusion was reached, and it starts with a little bit about light. As you can see here, when an object emits light and moves away from you, that light appears red, shifted in color. If the galaxy emitting light is moving towards you, it is blue shifted in color. So if it's moving away, red shifted, moving towards you, blue shifted. Well, let's take our hypothesis and see what happens. When a star is formed, it moves away from all other stellar objects. This means we should see every star red shifted since we are moving away from all other stars, and all other stars are moving away from our star. So that seems to make more sense in the universe expanding, so let's put a check mark there. Our next 3 mysteries are orbital anomalies and can be solved with our one hypothesis. But first, let's take a look at how orbits work. When a star is not moving and objects are moving around it in a circular orbit, it looks like this. Once the star moves, the orbit of anything around it will be affected because the orbit extends like a rubber band being stretched. So when a planet is orbiting a star and the star moves, the orbit deforms and the planet then has parts of its orbit work closer to the star and parts in its orbit where it is farther from the star than before. So with this in mind, this answers 3 questions when we apply the hypothesis that a star can move. Why Mercury has such an unusual orbit? Because the closest planet to the Sun would be affected when the Sun accelerates, be affected more than the other planets. This is why Venus has a greenhouse. It went too close to the Sun during an orbital distortion, and its water evaporated into steam. And this also explains why Earth has periods of ice ages, again it's farther from the Sun, and tropical ages, where its orbit is closer. So, that is 3 more mysteries that seem less mysterious. This brings us to our next mystery, a better explanation of pulsars and why they exist. Let's do a brief intro to pulsars. What is a pulsar? It is a star that is very bright, but is spinning rapidly, making predictable flashes of light. This flashing is so accurate, you could set atomic clocks by it. So let's look at why the universe would need a star that rapidly and accurately flashes. Let's take a pulsar that flashes once a second. So, if a star knows how fast a pulsar is flashing, that flashing will either slow down as the star moves away from the pulsar due to redshift, or speed up as it approaches a pulsar due to blue shift. Let's pretend you are a star that is moving. You require 1 pulsar, we will call P1, in order to determine your speed via flashing rate of pulsar. While speed is good, you also need to know what direction to move, since you're a little antisocial and want to move away from all other stellar objects. This means you require 3 pulsars, here P2 and P3. If you measure these 3 pulsars, you can get your vector direction, and now you know which direction and how fast you're moving in the universe. But what if you want a location in the 3D universe? Well, you need 6 pulsars for that. In math terms, you need 2 on each axis, the x-axis, the y-axis, and the z-axis, and then you connect them to find your location. So I won't put a check here since this is just a better explanation. It does not answer more basic questions on how pulsars actually function, but it is a better reason for their existence. All right, next one, a better explanation for black holes. They're my favorite astronomical thing. So, what are black holes? Doorway to another universe? A hole into nothing? Aliens? Isn't it always aliens? So if we use the hypothesis that stars can move, then a black hole would make more sense as a stellar graveyard and a recycling center. Why? Well, when a star dies, it just ends up a hunk of metal that is basically useless, a waste product mostly. Why not have a way to recycle nearly dead stars and other inert material? How? If you compress it hard enough, it can revert back into its most fundamental nature of energy and eventually can be remitted for reuse. Basically, you're turning a dead star into a new star. Of course, the only way this would make sense is if black holes ever randomly emitted massive amounts of energy. But according to supermath, again, general relativity, quantum mechanics, that is not possible because we all know nothing escapes a black hole ever. Well, I guess we have to give this one a miss. I can't win them all. Okay, moving on. Let's talk about quasars and provide a better explanation for them. A quasar is a quasi-stellar object. Quasi means not a star, but a big event. What is this event? Well, it is when a black hole at the center of a galaxy spontaneously emits a huge amount of energy. Wait a second. Let's look at my black hole explanation again. It looks like black holes do randomly emit massive amounts of energy. That's interesting. Well, I guess I'm going to have to put a check for both because I just like the check graphic. All right, let's move on. A better explanation for time dilation. I won't go into detail, but basically, the faster you move, the slower you age in relation to the rest of the universe that is moving slower than you. Humans will never really experience time dilation significantly, but stars do. Imagine you are still the star, and you are made up of fuel. This fuel gives you both life as well as movement. However, the more fuel you use to move, the less fuel you have to live on. So, why would you move then? Well, with time dilation, the universe basically says, if you move fast, young star, you will age slower and move farther as a result. The faster you move, the slower you age, and less fuel you need to live the same amount of time as other stars. And for a bonus explainer, this is also why light has to be constant in all reference frames. If it was not, then nobody could move since there would be no way of telling distance. The reason anyone knows accurate distance visually is because our brains know that light is a constant, and it has to be the same for stars since they're all undergoing different levels of time dilation. Finally, let's talk about fusion. Now, this is purely speculative on my part. There's no real evidence, but let's look at what fusion is. It is the sun in a bottle, as this book title elegantly states. So my pure speculation is that ELM is the initiation of plasma self-organization and cannot be controlled since it is trying to organize outside the constraints of the chamber. In other words, baby sun don't want to be born in no bottle. All right, to review, today we discussed ion drives and solar flares and how they are similar. We discussed some of the greatest mysteries of the universe and made a hypothesis to test against these mysteries. I hope you enjoyed this presentation. I will provide as many links as I can. Any questions, alternate theories, or creative insults? Appreciated.